Beneath the thick orange clouds of Saturn's largest moon, Titan lies one of the greatest mysteries in our solar system. Out there is a world that feels strangely familiar, yet completely alien. A planet-like moon that seems to echo the Earth in some remarkable ways. For many years, Titan's surface was hidden from view, covered beneath layers of thick haze. But NASA eventually found a way to look through that barrier and reveal the moon's true nature. And what they discovered changed everything we thought we knew about the outer solar system. Our first close look at Titan came in the year 1979, when NASA's robotic spacecraft Pioneer 11 made history as the first human-made object to visit Saturn. Its mission was to study the planet, its rings, and the many moons that surround the gas giant. Astronomers have known about Titan for centuries. It was officially discovered in 1655 by the Dutch astronomer Christian Huygens. As the name suggests, Titan is truly massive. It is larger than the planet Mercury and about 50% wider than our own moon. Yet despite its size, it is incredibly far away from Earth. So when Pioneer 11 finally reached Saturn, scientists were excited to see Titan up close. But all that the probe could detect was a thick orange atmosphere that completely blocked the view of the surface. Titan remained a mystery hidden beneath an endless layer of haze. Even so, Pioneer was able to study what that haze was made of, and what it found was fascinating. The spacecraft discovered that Titan had a thick atmosphere filled with nitrogen, which is very similar to Earth's atmosphere. The majority of our own air is made of nitrogen too. Then came another discovery that caught the attention of scientists: hydrocarbons. These are molecules made of carbon and hydrogen atoms. We use them every day on Earth in the form of fuels like gasoline and propane. But on Titan, hydrocarbons appear naturally in the form of methane gas, which we also know as natural gas. This was a very important finding for NASA, because hydrocarbons are not only potential fuel, they are also the building blocks of life. Every living thing from DNA to proteins is made up of carbon-based structures. Here is a more familiar word: carbohydrates. They are very similar to hydrocarbons, but they also contain oxygen. So if oxygen could also be found on Titan, it would mean more than just the building blocks of life. It would mean the fuel to support life itself. And yes, oxygen does exist on Titan, but it is not easy to find. To uncover it, we have to go much deeper beneath the icy surface. So keep watching, because that is exactly what scientists planned to do. Next, flying a probe close to Titan also helped scientists understand the moon's gravity. And this turned out to be quite unusual, because Titan has much less gravity than anyone expected. For a world that is larger than our own moon, the force of gravity on Titan is actually a little weaker. This means Titan is not very dense, which also means it cannot be made entirely of rock. That idea opened up new possibilities. The mix of a thick atmosphere and weak gravity would make it possible for a person wearing a wingsuit to jump from a cliff and glide through the air for as long as they wanted. It would also make a flying machine the perfect tool for exploring the surface. So this was what NASA found in the late 1970s. Many Earth-like ingredients hidden deep within the outer solar system. Beneath Titan's clouds could lie a discovery that might change everything we know about life and the universe. It was close, but still so far away. Technology would have to catch up before we could see more. 25 years later, in 2004, the Cassini spacecraft finally arrived at Saturn, ready to continue where Pioneer 11 had left off. This mission was a joint project between NASA, the European Space Agency, and the Italian Space Agency. Cassini carried advanced radar and infrared instruments that could see through the thick atmospheres of both Saturn and Titan. Over the course of its 13-year mission, Cassini flew past Titan 127 times, using its instruments to cut through the haze and study the surface in detail. What it revealed was beyond imagination. Titan is the only moon in the solar system with a thick atmosphere. In fact, it is 4 times denser than Earth's. This thick air creates a kind of reverse greenhouse effect. It blocks out what little warmth from the sun can reach that far. As we move closer to Titan's surface, the methane gas in the air gets colder until it turns into liquid and falls as rain onto a crust of solid ice. The average surface temperature on Titan is minus 179 degrees Celsius, and methane freezes at minus 182 degrees Celsius. This makes Titan the perfect place for a complete cycle of evaporation and rain, only with liquid methane instead of water. The result is a landscape covered with rivers, lakes, and seas. Titan is the only other known world besides Earth that has stable liquid on its surface. The scientists who built Cassini knew Titan would reveal something extraordinary. That is why the European Space Agency included a second probe. On board it was called the Huygens lander, named after the astronomer who first discovered Titan. It was designed to descend through the atmosphere, take pictures, and study the surface up close. In January 2005, Huygens began its descent based on images captured by Cassini. The landing site was believed to be near the edge of a small lake. The probe was built to survive many different conditions, including rocky terrain, flat plains, and even liquid seas. It had enough battery power to work for 3 hours. 2.5 of those hours were spent gently parachuting down to the surface. As Huygens passed through the clouds of Titan, the first images began to appear. A dark valley stretched between brighter mountains, and as the probe moved lower, details started to form. In the center of the frame, scientists could see networks of channels and streams cutting through the slopes of the mountains. Some were hundreds of meters wide and several kilometers long. These had likely been carved by methane rain running down into the valley. The probe descended right into the middle of that dark plain, and as it approached the surface, it became clear that no liquid was present. Huygens was landing on a dried riverbed. When it made contact with the ground, it pressed 12 centimeters into the surface, bounced once, slid about 30 centimeters, and then came to rest. When the camera looked around, the most surprising thing was not how alien the world looked, but how familiar it seemed if the orange color were removed. The scene could pass for the bottom of any river on Earth. Large, smooth stones lay scattered across a sandy surface surrounded by smaller pebbles. But these were not rocks. They were pieces of water ice, frozen as hard as stone. The mountains were also made of ice, and where there is ice, there is water, meaning oxygen, H2. Oh, but that water was frozen solid and could not support life. The surface around the lander looked muddy, yet it was made of a strange hydrocarbon, material that felt like snow with a crisp top layer and a soft texture underneath. As the camera scanned the horizon, small waves appeared in the air created by the heat of the probe's lamp, causing bits of surface material to evaporate. At one point, a tiny drop of methane dew slid down across the lens. When the camera looked upward, it saw the sun in the orange sky appearing only 1/10 the size it looks from Earth. Even though it was midday on Titan, the light was as dim as twilight on Earth. Huygens had uncovered a landscape that was both alien and familiar, but it still did not solve the biggest mystery of all. The probe had landed in what looked like a river, yet there was no liquid methane to be seen. So where had it gone? One of the most interesting discoveries from Huygens was about Titan's methane cycle. On Earth, we have the water cycle. Water evaporates from the oceans and rises into the sky, where it condenses into clouds. When enough vapor builds up, the water falls back to the surface as rain on Titan. A similar process happens, but with liquid methane instead of water. Because Titan receives very little sunlight, the methane on the surface evaporates very slowly. When it finally does, the vapor collects high in the dense cloud layers above. The clouds can hold enormous amounts of methane before it begins to fall as rain. The result is a long dry period that can last for hundreds of years, followed by short seasons of heavy rainfall that cause massive floods across the surface, so when Huygens landed, Titan was likely in a dry season. It did not mean the moon was always dry, though. As Cassini continued its 13-year mission, it kept observing Titan carefully. Over time, the spacecraft learned that during dry seasons, most of the liquid methane moves toward the northern polar regions. From its orbit, Cassini detected bright reflections of sunlight glimmering on the surface of the North Pole. These reflections came from large lakes of liquid methane. The first one ever identified was named Ontario Lacus, after Lake Ontario in North America, because the two have almost the same shape. The version on Titan is about 20% smaller, yet it still covers 15,000 square kilometers. Although Ontario Lacus is quite large, it is not very deep. The average depth is between 40 centimeters and 3 meters. The lake is also strangely calm, with waves rising only a few millimeters high. To the naked eye, the surface would look completely smooth and still, like glass. Scientists are not sure why that happens, since Titan has lower gravity and higher air pressure than Earth. The waves should actually be taller. Lake Ontario on Earth often has big waves, but Ontario Lacus on Titan remains almost perfectly flat. Titan also has a massive sea near its north pole called Kraken Mare. It covers around 400,000 square kilometers, which makes it slightly smaller than the Black Sea on Earth. This sea even experiences tides caused by Saturn's gravity. The level of the liquid methane rises and falls by about 1 meter. Kraken Mare is shallow for its size, averaging 300 meters in depth, while the Black Sea on Earth reaches more than 2,000 meters. But Titan's surface is not shaped only by lakes and seas. There are volcanoes as well, though unlike those on Earth, these do not erupt with molten rock because the surface is made of ice. Instead, they erupt with slushy water mixed with ammonia, creating a form of icy lava. If Titan is so cold, then how can there be any water that is not frozen solid? The answer lies in the presence of ammonia, which acts as a natural antifreeze. Most people know ammonia as a strong-smelling cleaning chemical, but it was also very common during the formation of the solar system. It is made of nitrogen and hydrogen, two of the most abundant elements in the universe. During the early stages of planetary formation, ammonia became mixed with ice and rock and played a major role in shaping the environments of moons and planets. On Titan's surface, any ammonia would have slowly evaporated into the air, helping to create the nitrogen-rich atmosphere. But deep below the surface, it would have stayed trapped within the icy crust. There it mixed with water ice and kept parts of it from freezing completely. Solid scientists believe that below Titan's hard outer crust lies a layer of partially melted ice slush that can sometimes escape to the surface through cryovolcanoes underneath that slushy layer. There may be a deep underground ocean made of liquid water that sits on top of a rocky core. There is enough heat and ammonia beneath the crust to keep that ocean from freezing. That means Titan could have all the key ingredients for life: water, hydrocarbons, and the natural chemistry that links them together. On Earth, when water and hydrocarbons combine, they form carbohydrates, which are essential for living things. If similar reactions are happening inside Titan, then even simple microorganisms could possibly exist below the surface through this active process of icy volcanoes and chemical mixing. Titan creates the perfect environment for organic chemistry to take place. We are not saying that there are aliens on Titan, but the basic conditions for life might already be there. That is why NASA is now preparing a new mission called Dragonfly. This is a nuclear-powered drone that will fly across Titan's surface and collect samples from different regions. It will carry a full laboratory inside to study the soil and atmosphere directly. Dragonfly is planned to launch in the year 2028 and reach Titan by 2034. It will be one of the most complex and ambitious missions ever attempted in space. The goal is to explore multiple landing sites, analyze the strange sand-like snow on the surface, and search for signs of chemical activity that could hint at life. If life exists on Titan Dragonfly, will give us the best chance to find it. It will help answer one of the most important questions of all, whether we are truly alone in the universe. Thanks for watching.